Welcome. We're going to switch gears from addition to subtraction. And it's kind of really important to understand that these two things are actually very much hand in hand. We're going to go through a bunch of these things that are on the thing. We're going to talk about what is subtraction by just looking at some different visual ways to attack it. Talk about the inverse relationship between addition and subtraction, how they undo each other. And we'll go through some different algorithms, including what's known as the standard algorithm. And I'll show some other things. So let's just talk about this for a second. So first off, what are some of the different ways in which we can model? One is called the takeaway model, and that is by giving a set of objects and taking stuff away. Makes sense. Number line model is using the number line, and last, the missing add-in model. And this is more of an algebraic type, and it's almost guess and check, but we'll get through it and it'll make sense. So takeaway, like here, 8 minus 3, you start with 8 blocks, you take away 3, you say what's left, they count them, they get it. So this idea of what is subtraction is taking something away that was already in there. So this is a great way when you're just counting it. Again, though, the problem is if you're going to remove, you have to count the things you're going to remove. That's kind of frustrating. And you then have to count what is left. Again, frustrating, even with the 10 blocks and so forth. The number line model, again, gets this number line idea. So if we start with 5, so as you can see here on the screen, we start with 5, we go all the way to 5, and then we come back 3 steps. What's left over? It's 2. So that is 5 minus 3. This idea, similarly, like I did on the previous, so if I was to draw a number line, here's 0, here's 5, and you can just go back 1, 2, 3, that's 2, so we're good. So the answer is 2. So again, you're just counting the jumps back, and we get this idea. If I go 5 and goes backwards 5, it's this. Now, the really cool part, and this is how this attaches to addition. Addition, which direction we move? Addition moved to the right. So that was addition. Subtraction, on the other hand, moves to the opposite direction. So this idea that subtraction is doing the opposite. So if one moves to the right, the other one must move to the left. Helps them see opposites very clearly. Well, what we can do then is we can get to what's called the missing add-in. So if I do 8 minus 3 is what? Instead of looking at this, you're almost getting them to ask the question of 3 plus what? So notice I took the thing that was being minused. I moved it to the other side and said it plus what? So this gets the idea of what is algebra without using an X or any other scary algebraic things. We'll get some algebraic stuff in class, but even before you do algebra, it's really a question of I'm just putting a placeholder. 3 plus what is equal to 8. This is great if they already know their additions and they're very, very comfortable with them. And in fact, they could still, if you gave them this problem, they could start with 3 fingers and say, okay, let me see. If I count the next would be 4, 5, 6, 7, 8. Oh, I counted 5 more. So therefore I have the answer is 5. So again, they can use their addition skills to kind of get through this model. And this idea, I mean, whether you want to look at it as I have 3 blocks, how many more blocks do I need so I get a total of 8? If you want to use it using the number line, all of these are just visualizations of letting students actually play with it. Let me give one more. It's called the comparison model, and it really is just the same thing. I'm comparing, so the question is, Juan has 8 blocks and Susan has 3. How many more blocks does Juan have than Susan? Well, notice that we take what they have in common, group them together, and essentially eliminate that, and what's left over. And that gives the idea that subtraction is just using the leftovers of our specific problems and not actually having to worry about the actual calculation and so forth. Now, this kind of gets back to one of the major properties of addition, which is, subtraction, which is if you take two, if you give me a couple numbers, if I say 5, 9 plus 5 is some number, and 12 minus something is 4, can it be, these can be true depending on this idea. So this is how algebra comes in, but we get this idea of playing around. The star, if star is 10, then 9 plus 5 is 10. It's not, I mean, sorry, sun, that's not true. And if diamond is 8, then 12 minus 8 is 4. Well, that is true. We can double check it, but because 8 plus 4 is equal to 12. So this is the idea of how to solve equations. So doing this actually and introducing it, it's usually this is introduced a little bit actually in some younger grades of first, second, third. You wouldn't think of they're doing algebra, but they have. So instead of using a letter, they're just using a symbol or a box, and they're trying to solve this thing to make it true. So students can use their own brains to kind of work their way through it, and that's how they kind of come to understand this. All right, so let's talk about a little more about some different subtraction algorithms. Namely, let's talk about what's called the concrete. So if you just literally wanted to do 243 minus 61, we'll have 243. I'm going to start with this. I want to take away 61. So the first thing I can do is let's remove the 1, and then we can remove 6 longs, but we have to trade. So in other words, I'm going to have to take this thing right here, because notice I don't have enough long sticks. I only have 3 sticks, and I have one big old block, one big old chunk right here. So we have to break this chunk into 10 sticks. Boom. There we go. Now we got 10 sticks. Now we say, let's remove 6 of those sticks and 1 of the single blocks, because remember taking away 61. So if I take those away, cross them out, then I say, okay, I have 100ths, and I have 1, 2, 3, 4, 5, 6, 7, 8 tens, and 2 singles, which gives me 182. So this idea, and then you can even redraw it just simply this way and still get the same thing. So this is a great way to still work with it, this idea of borrowing, because you're not borrowing to them. They can look and visually look at, I'm just going to come back to this original thing, that here you actually have 10 strips that are all kind of glued together. So to speak, we're ungluing them so we can use them and get our number back down. All right, so what about this problem? This is another strategy. So in this one, I want to subtract an easy number. So let's just stop for a second and don't ignore all these steps over here. Ignore everything over here. Okay, let's just focus on this. If I gave you 255 and I said minus 200, is that a lot easier than 255 minus 163? Hopefully you're probably thinking, yeah, it is. So this is a strategy to make our numbers easier. So we start with 63. The number we're subtracting, we say, how do I make that a nicer number? Well, 163, if I add 7 to it, it'll become 170. That's a lot nicer number. But if I add 7 to the thing I'm down here, I got to keep it balanced and add 7 to the top. Because imagine a scale, I'm taking away. So if I'm taking away 7 extra, I have to start off with 7 extra in the first place. So put 7 more. So 255 plus 7 gives me 262. Now 170 plus 30 is going to give me a beautiful 200. So again, I have to give 30 to the top, which 262 plus 30 is 292. And now we have 292 minus 200, which is a very simple calculation to get our very nice, easy 92. This is kind of a great way to do this, but it again requires you to understand how do you get from 163 to 200, and the best way to do that is little chunks like this, like add 7 and then add 30 and do that. And then, by the way, this is a great mental math strategy. I actually employ this sometimes when I have to do mental math in the store and other things like that. Another store strategy, just to mention, is called counting up algorithm. Now, I don't know if any of you have ever been a teller somewhere and you're used to your machine tells you this is how much change you're supposed to get. Well, even with that, if old school tellers, maybe you've ever been around a cashier, they actually count out the change back for you, counting from what you paid up to the amount that you gave them or paid them. Now, this isn't as big a thing because we don't have as much cash anymore. This is something I did have. One of my first jobs was as a cashier early on in my college career. And so I remember doing this very thing. So this idea is I'm going to get from 39, 31. So let's say you gave me $100 for a $31 exchange. The first thing I do is I'm going to give you $9. Now, is that 9 ones? Is that 4 ones and one $5? Doesn't matter. I'll give you 9 ones. It gets you $40. And then I can say, okay, let me give you a bunch of 20s. So 40 plus some more and more and more. Now we're at 100. And so I gave you change of $69. And that's how it works. Let me show this a different way, actually using a store example. So consider this example. Noah is buying groceries and he has $11 in groceries. And he gives a $50 bill to the cashier. Well, the cashier can literally starts with $11 and then gives him $1 bill. Well, now and goes 11 and then puts $1 bill in their hand and says 12. Puts the next dollar bill in their hand, says 13. The next one says 14. Next one says 15. At this point in time, they hand them a $5. So it goes from 15 to 20. And then throws in a $10 bill, which gets it to 30. And then throws in a $20 bill, which gets it to all the way up to 50. So as you can see, you're like 11, 12, 13, 14, 15, 20, 30, 50. That's literally what they would say as they hang you these bills. Well, what's that mean? Well, essentially, if we added up all those numbers, we get 39 because 1 plus 1 plus 1 plus 1. This is $4, and then that's $5, and that's $30. So that's $39. So 50 minus 11 is going to be 39. Because 39 plus 11 is 50. So this idea about how these things work with each other kind of makes sense. All right. Let's kind of skip ahead. I'm going to skip, and I want to talk just about the standard algorithm. Many of you know, but let's just talk about some mental calculation strategies. Namely, if I'm going to do this where I'm going to break up, so 74 minus 76. Well, instead I say, what is 74 minus 20? So in other words, I take away the tens place first. Well, 74 minus 20 is 54. And then I take away 6 more to get 48. Now, how do we do this? Well, there's lots of ways you can do that. You can start again with your fingers. On your fingers, you say, okay, I'm at 54, and I'm just going to count down. So one finger makes 53, 52, 51, 50, 49, 48. I got 6 fingers up now, and I've gone down 6. So I'm at 48. The downside is if you don't start counting at the right spot, don't move your fingers, can't count down, count up as well, this does become problematic, but it can be very useful to break up the problem into smaller chunks and again, make it easier. Another great one's called trading off. Again, this is very similar to what we had before, where I'm going to say, okay, I want to make 26 a nice number, 30. So I got to add 4 more to it to make it 30. But if I go 4 more there, 74 must go higher. So it's up to 78. One way I've also seen this one done is this. So people in their brain go, okay, 26 plus 4 is equal to 30. And then they go from there, they do 74 minus 30, which is 34, and then realized if I essentially took away an extra 4, then I'm going to have to I'm going to have to add those back in here. So I go plus. So then we just take that and take 34 plus 4 more. Oh, sorry, this should be 44. Wow. I'm doing great here. 44, and then I got 44 plus 4, which is 48. All right, so we have this great thing. We can kind of work through it. kind of see that. So that's the really another great mental strategy that does come up a lot is dropping zeros. Namely, if you got 74 minus 7,400 minus 600, we simply ignore the common zeros and make this 74 minus 6, 68, and then add the zeros on again. This is great for place value and helping students understand that when you're just adding hundreds, just focus on the hundreds. When you're adding thousands, just focus on the thousands. Breaking them up into separate parts, that expanded form, tends to make the problem much easier and help a lot of students. All right, hope that makes subtraction a little bit more clear. Good luck. Let me know what questions you got.